Good evening, my dear students, and welcome to the science classroom. And we are now dealing with chapter 3, which is dealing with atoms and molecules. Day before, the laws of chemical combination, and yesterday we studied the Dalton's atomic theory. And Dalton considered atoms as the smallest minute particle of a matter. So today we are going to study what is an atom. What is an atom? So let us take 2 or 3 examples. The first one, while we are going our trip from our school, okay, the study trip from our school, or that time we are going to a seashore. We are having a lot of seashore in Dakshin Kannada and Uttar Karnataka. So if you go there, if you take a little sand and spread it in your hand, you can see tiny particles there. And one more example, if you see the ant hill near your surroundings, you see that the ant hill is made up of small particles. I say the atoms are still smaller than that. Okay, that type of small, still smaller particle it is. So the third one is a mason building a wall. Okay, what is the relation between this? This sand is mixed in some proportion to other materials, and the bricks are made. By using these bricks, walls are made. By joining walls, rooms are made. By adding rooms, houses or buildings are made. So for constructing different things for our use, it is essential. Okay, by combining this small minute parts of different elements or substance, and we are forming different higher level or big buildings or whatever we need. Okay, so we are going to define atoms. We can say that the building material, the building block of matter, the building block of all matter are called an atom. The building block of all material, the building block of all material are called atom. Okay, then next let us check how big are the atoms. How big are the atoms? How big are atoms? I said, if you take the sand in your hand, a little sand in your hand, you are spreading it, you can see a very, very tiny particle. The atoms are even smaller than that. Even smaller than that. Okay. It is very smaller than what we can imagine. It is the smallest thing. Okay. Or the thing which we cannot imagine, or whatever we compare, the thing is lesser than, the atom is smaller than that. Then if a million, in your textbook it says that if a million of atoms are spread like a paper, it won't give the thickness of a paper. Millions of atoms are spread, it won't give the thickness of a paper. See, then how much millions, okay, millions of atoms are spread means. So then what will be the size of an atom? Too small. Okay, then what about radius of atom? Next we are going to study about radius of atom. Okay, it is radius of atom is measured in nanometer. Measured in nanometer. Okay, measured in nanometer. That is 1 by 10 raised to 9. 1 by 10 raised to 9 meter is equal to 1 nanometer. 1 by 10 raised to 9 meter. So 1 meter is equal to 10 raised to 9 nanometer. Okay. 1 meter is equal to 10 raised to 9 nanometer. It is measured in the radius of the radius of atom is measured in nanometer. For understanding more, let us compare with some other items which we are seeing in our daily life or in our surroundings. I am going from big to small. Okay, in your textbook it is from small to big. I am going from big to small. I will write the radius. Okay, and example I will write here. Okay. It is in meter. In 10 raised to minus 1, there is watermelon. Ten raised to minus 1 meter. You can see watermelon. This only this much or maybe this much. Okay, this is the size. Maybe this one is the size of one watermelon. That means the 1 meter is divided into 10 and one part of that is the watermelon. So next the radius in meter is 10 raised to minus 2 meter. Okay, in that comes and. Okay, 10 raised to minus 2 comes and how much small it is? Too small, and you can see very small. Okay, 10 raised to minus 2, that is and. Then 10 raised to is doubling. Everywhere you can see minus 1, minus 2, minus 4. This doubling again, it comes the grain of sand. Grain of sand means very little. I said when you take the sand from the seashore and you are spreading, you will get a grain. 1 grain. Okay, 1 grain is 10 raised to minus 4 meter. Okay, 1 grain of sand. Grain of sand. Then 10 raised to minus 8. 10 raised to minus 8. That is molecule of hemoglobin. Molecule of hemoglobin. See, till here we can see somewhat. Till here 10 raised to minus 4 we can up to 10 raised to minus 4 we can see. But 10 raised to minus 8 molecule of hemoglobin. From that it is invisible. Then with microscope we are able to see. Then 10 raised to minus 9. 10 raised to minus 9. 10 raised to minus 9 molecule of water. Molecule of water. 10 raised to minus 9 comes molecule of water. Then 10 raised to minus 10 comes the hydrogen atom. Hydrogen atom. So you compare watermelon, this much big, second, and this much big. Then grain of sand, too little. Molecule of hemoglobin, invisible, very little, can see through the microscope. Molecule of water, Same. Then from there also too much of this difference is there between this. So 10 raised to minus 10 hydrogen atom. Very, very minute. Okay, one atom is very, very minute or so tiny. Then for us, a question you understood till now, the atom is too small. Can you see a small little bit chalk powder is in my hand? Can you see this? That much of very tiny, very tiny. I said no. You understood now. It is very small particle. So you may think it is very small. So why should we care about that, or why should we think more about that? We care about them because our entire world is made up of atoms. I said in case of that sand, the sand is mixed up with some other substance, and walls are made, rooms are made, like that. Every substance are made up of atoms. We may not be able to see the atoms directly, but they are affecting whatever we do. Everything, this chalk and this material, everywhere, it is made up of the substance. The substance used for making this one is made up of tiny particles called matter. Sorry, atoms. So till here you understood what is atom. Okay, the smallest, we will say, the building block of all matter. The building block of all matter are called as atom, and radius of atom is measured in nanometer, which is 1 meter is equal to 10 raised to 9 nanometer. Then we are going to study about modern day symbols of atom. Modern day symbols. Modern day symbols of atom. Okay, of atom. And how we studied last day about different scientists and their observation. I am taking John Dalton. Let us see what this scientist suggested. John Dalton is the first scientist to suggest a symbol for an element. Okay, he is the first scientist to suggest a symbol to an element, and when he suggested the symbol, it was of definite quantity. Okay, it was of definite quantity of element. Okay, it was of definite quantity of the element. And another one scientist, Berzelius stated that the symbol of elements can be made from the first one or two letters of the elements. Let us check some of the symbols made by Dalton. Okay, symbols made by Dalton. Let us check. And this is hydrogen, and like this comes carbon, and it is like oxygen. These are the symbol given by Dalton. Okay, Dalton. John Dalton, the scientist John Dalton. The scientist John Dalton. Okay, and phosphorus and sulfur and iron. Then copper, then lead, then silver in S is silver, then gold, 8 hands like clock, 4, 5, 6, 7, 8. This is gold. Okay, gold. And platina, and mercury is having 8 dots. This is mercury. These are the symbols given by Dalton. These are the symbols given by Dalton. And let us check how the scientists named and which are the, how in modern day the symbols are made. We will study. Okay. In the beginning, where the elements were found, according to that the name was given. For example, copper, it was seen in the place called Cyprus. It was seen in the place called Cyprus. So, some taken from color. For example, color. Okay, color. Gold was taken from color. Okay. The meaning of yellow is gold in English. So, the gold is the English word for yellow. So, for gold, because of the yellow color, it was given gold. The name was given gold. Then, nowadays, the naming is approved by whom? Did you heard about IUPAC, International Union of Pure and Applied Chemistry. International Union of Pure and Applied Chemistry. That persons will approve the names of the element which have been suggested. And the naming we studied by the place of origin and the color is over. Then what are the other factors? Some of the the symbol have been made by using the first and second letter. For example, first and second letter. First and second letter. For example, argon. AR, first and second letter, and bromium. BR. Okay. BR. Bromine. Sorry. Bromine. BR. Okay. So, and how when we are writing the symbols, the first letter should be capital. For example, while we are writing hydrogen, it should be H, and if we are writing aluminium, it is first is capital and second is small. And don't write both capital, it is wrong. Okay, if we write AL means it is wrong. First is capital and second is small. Okay, then And for some elements, it is taken the first and some other letter. For some elements, the symbol is taken from the first and some other. Okay, some other letter. Let us see which are they. Chlorine. Did you heard chlorine? Chlorine. First letter is C and the symbol we will write Cl. Okay, this is L is the third letter. The first and some other letter. Okay. Then some of them have been taken from the Latin, German or Greek. For example, iron, Latin, Greek or German. Okay, Latin, Greek or German. For example, for iron, it is ferrum in Latin and iron, ferrum in Latin, so Fe. Understood? And there is a table which give you a brief and important elements, symbols. Okay, in red column there is in page number 44, I think. Symbols for some elements. Symbols for some elements. Symbols for some elements. Just go through the symbols for some elements and just go through that, and we will study these things, the symbols, when it is useful. Anyway, little bit try to study the symbols. Okay, it will be useful for you when you are performing more in chemistry. So this is all for you today, and you check the video, and you study. Any doubt means let me know, and I'm hoping that you are studying well. So thanking you. Bye.